Welcome to solverfy.
In this question, we have a random orbit sender setup. So the motor in the center drives gear A. The radius of gear A is 10 mm. Gear A is matched with gear B, where the radius of B is 40 mm. Shafts CD, spindle DE. Based on the diagram, they are going to rotate with gear B, and spindle DE is 15 mm away from shaft CD. The question is, we want to find the magnitudes of the velocity and the tangential and normal components of the acceleration of spindle EF at t equals to 2 seconds. Okay, so to solve the problem, here we are given that omega A changes with time according to this formula, 40 t cubed plus 6t. So alpha A will just be d dt of omega A, and this is equal to 40 times 3t squared plus 6. Okay, then so at t equals to 2 seconds, we can find omega A to be 40 times 2 cubed plus 12. So this is 800 radians per second. And then alpha A is 40 times 12 plus 16 plus 6, sorry. And so this is equal to 720 radians per second square. So as we mentioned before, A is matched with B. Okay, so which means that omega B RB equals to omega A RA, and alpha B RB equals to alpha A RA. Okay, so we want to find omega B. It's just RA divided by RB times omega A. So this is equal to 10 divided by 40 times 800. So omega B is 200 radians per second. And then alpha B, same formula, RA over RB times alpha A is 10 over 40 times 720. So this is 180 radians per second square. Okay. So now we are ready to find the relevant quantities for spindle EF. Okay, so the speed is omega B times R. So this is 200 times 0.015, 15 mm, convert to meters, and we get the speed is 3 meters per second. The tangential acceleration is alpha B times R, which is 180 times 0.015. This is 2.7 meters per second square. And then the normal components of acceleration, omega b squared times r, this is 200 squared times 0.015. This is 600 meters per second square. Okay, so here are the answers. This is the magnitude of the velocity of spindle EF. This is the magnitude of the tangential acceleration. This is the magnitude of the normal components of the acceleration.